Okay, YouTube, this is my last video in my module on applications of linear systems, in which we're going to look at an investment situation. These are pretty common problems that you see from time to time. Let's go ahead and read through it and start by defining our variables here. So it says that a person invested $7,000 for 1 year, part at 4%, part at 5%, and the other remaining at 7%. So the total annual income from these investments was $380. It says the total amount of money invested at 7% was $3,000 less than the amount invested at 4% and 5% combined. So what we want to do is really find the amount that we've invested at each rate. And so essentially, since we have three rates here, we're going to need to define each of our three variables in terms of how much we invested at each rate. And so I suppose we could say this is the number of, and we're investing in dollars, but we say number of dollars invested at, and I'm going to go with my first account here at 4%. So this will be number of dollars invested at, it looks like 5% was our second account, and then the remaining funds had been invested at 7% here, so 7%. So defining our variables thusly, what we want to do is, of course, go back and write our system from these equations, but what we want to do is make sure that we match up units. Now, in terms of units, I noticed that there are these numbers. For example, $7,000. What would this in money here represent? We'd say, well, that $7,000 really, that was the total amount invested. And so since we have the amounts invested in each individual account, if we want the total amount invested, what we would do is we would just say the number of dollars at 4% plus number of dollars at 5% plus the number of dollars at 7%. This would have to come out to be 7,000 total dollars. And so in terms of equations, at least with investment equations, oftentimes you'll see a totals equation that says, well, the total of all of your stuff here comes out to be this. So now that we've accounted for the 7,000, one thing that I do want to talk about in this problem is that it says that the total annual income from these investments was $380. So in terms of income from investments, the way this works is essentially if I give you a 4% rate, what we're saying is for every $100 you invest, say for $100, say for instance, what I'm going to do is I'm going to give you 4% of $100. And so the thing we want to recognize is that if you want to find 4% of a number, what we do is we take 0.04 times that number. So for instance here we would get 4. But that's because 4 is 4% of 100. Now, in terms of 100, I just chose $100, but how many dollars really are we investing in this fund? We would say, well, we're investing X dollars, and what we want to do is find 4% of that amount. What that would equal is the amount of interest income at 4%, since we said 4% of what we invest at 4%. So to put this together, what we often see is this equation where we say, well, if I wanted to know, then how would I find my total investment income? Then what we would say is that, well, we'd have to find 4% of all of the dollars we invest at 4% and add that on to 5% of all of the dollars we invest at 5% plus 7% of every dollar that we invest at 7%. This would come out to be our total interest income, which in this particular instance comes out to be $380. And then the last statement that's made here is basically the total amount of money invested at 7% was $3,000 less than the amounts invested at 4 and 5% combined. So to kind of interpret this in terms of our symbols here, when we say that the total amount of money invested at 7%, the letter we're using to represent our 7% fund here is Z. So recognizing that we're saying that the amount invested at Z is or was equal to 3,000 less than the combined amount for 4% and 5%. So for 4% and 5%, these are our X and our Y combined. What that would do is it would say that our combined amount really then would just be X plus Y, and we want 3,000 less than this, which would mean that we're going to have to take 3,000 off of this. So to set this up, what we're looking at is the amount of dollars at 7% is the combined amount in our 4 and 5%, but 3,000 less than this. And so what we have here is this system that's set up kind of interestingly. You can see that this last equation is most definitely not in standard form. So the first thing I'm going to do is I'm going to take my X and my Y and I'm going to move them over to the left side of this third equation. And I'm going to rewrite my system here so that now what we end up with is on our first equation, X plus Y plus Z, or the total of our funds, was $7,000. And in our last equation, we get negative X, okay, minus Y plus a z, and this is equal to the negative 3,000 that we would have left on the right hand side. Now, there is one thing that you notice I did here. I've left out the second equation, and the reason why is really because I have all of these decimals right here. And so because they are so unattractive, I will just go ahead and say it, because they're so undesirable, what we're going to do is we're going to take this entire second equation and we're going to multiply it by 100. But the reason why is because I know that 100 is really 10 times 10. And I know that every time I take a number times 10, what I'm doing is I'm moving the decimal to the right. So suppose that I recognize that if I take everything times 100 here, what's going to happen is it's basically going to eliminate the decimals on these three coefficients. And I would say more generally speaking, what we'll do is we'll shift the decimal place on all of our values across this entire equation 2 spaces to the right. And what that does then is it generates a new equivalent equation which would instead say 4x's plus just 5y's plus 7z's once we've moved all of these decimals twice to the right here. But would it be equal to 380 when we move its decimal twice to the right? Or in other words, 380 times 100. So now we get this new system here, and I'll put a box around this because this is the most desirable form of this system in the first place. So in terms of solving for this, let's go ahead and recognize that the first thing we want to do is find a variable to eliminate in 2 different pairs of our equations. So for instance here, I noticed that if I were to add equation 1 to equation 3 right now, our x's would cancel out. So I'm going to go ahead and proceed to go ahead and rewrite these and then start to move forward with canceling out some variable values here. So we say plus z is equal to negative 3,000 here. And so what we end up with is our x's and y's canceling. We end up with 2 z's, and I didn't see this coming, but one thing we're already aware of right off the bat then is that we have in at least our last account here. So when we write our solution, we've just determined then that in our z account we have $2,000 invested there. So if z is equal to 2,000, what we want to do now is go back and solve for y and x. Now the interesting thing here is that we've already solved for z, and that was with equations 1 and 3. Our goal was to use 2 different pairs of equations to eliminate x's within. So for instance here, what if now we were to use these 2 equations? We say 4x plus 5y plus 7z. This would be equal to our 38 with 1, 2, 3 zeros after it. And then this last equation here, let's say we were to take this entire last equation times a negative 4. What we'd end up with here, or not a negative 4, but a positive 4, we'd end up with a negative 4x, a negative 4y. When we distribute 4 times a z here, we get a positive 4z. And I suppose 4 times a negative 3 would be negative 12, so we'll just say this is negative 12,000. What's going to happen is we're going to get our x's to cancel out like we wanted to, and we're left with this equation that has 2 variables, a single y. It looks like we have 11 z's, and when we add these 2 values together, I suppose 38 minus 12 would be 26 and 3 zeros after this. So I'm going to put a box around this. Now, typically with a 3 by 3 system, we would have already done this. We would have had 2 equations and 2 variables, but because we already were able to find out z, what I'm going to do is I'm going to take this z and we're going to plug it back into this other equation that had 2 variables in it, and we're going to solve for the value that is in our y account. So looking at this here, suppose we would have y plus 11 times z is equal to 26,000, and if we would plug in a 2,000 here, we would get this. We get y plus 22,000 equals 26,000, and by subtracting 22,000 from both of these sides of this equation, we get y equals 4,000. So I'm going to box this here. I'm also going to put it up here in our ordered triple, 4,000. So now that we know this, I'm actually inclined to put this back into our first equation. We would say that we have x plus y plus z is equal to 7,000. Okay? And we knew that, or we know that now, we have 4,000 invested at the y account there and 2,000 invested in our z account. What we really come up with this is this x plus 6,000 is equal to 7,000. So the only value I could think of that I added to 6,000 get 7,000 must be 1,000. I'll go ahead and put this back into here. And so in terms of our context of our problem, like what could we interpret this as being the truth here, or what did we decide about this investment? And so the question was, how much did we invest at each rate? And so we would say that we invested $1,000. Oh, my keyboard's being a little funky here. Sorry. Let's try this. Well, it's not that important that I write that out, but we want to acknowledge here. Let's see if I can get this to work here. There are $1,000 invested at 4%. we've got $2,000, no, $4,000 invested at 5%, and we had, I suppose, looks like $2,000 invested at 7%, if this is the case. Cheers.